Okay, so 11. Oh, hold on. All right. So 11.1. Find the number of possible lessons placed, each consisting of 2 letters and 3 numbers given. Given the following parameters. For these questions, we're going to be having the letters first and the numbers second. So for number 1, it says exactly 1 letter must be a vowel. So if we start with that, we have 6 vowels in the English alphabet. And so once we take care of that first parameter, then we can handle the second letter, which has no strict parameter on it. So we can choose any letter in the alphabet. And then as for the numbers, they don't have any parameters. So you can have 0 through 10. 0 through 9, my bad. And that will get you 156,000. And this is the basic counting principle we're solving these by. For number 2, it says the numbers can't repeat. So as the letters have no set parameters, we're just going to be able to choose all 26 of them, even if they repeat. But for the numbers, for the first number, we can choose like 0 through 9. So that's all 10 numbers. For the second one, we can't have a repeat, and whichever number we choose for the first digit, then we can't use that again. So that automatically takes out 1 possibility, which will give us 9 possibilities in all. And then again, we take out another possibility because of that 9. Now we have only 8 possibilities for choosing numbers because no numbers can repeat. And then that will get us 486,720 possibilities. 11.2, we have how many ways can 3 men and 5 women be seated at a round table relative to each other? What I meant was just how many ways can they just sit at a round table? I don't really know what relative to each other means. I don't know if that really changes anything, but it's just a normal seating problem. For this one, we're going to use a circular permutation with no flip because these are humans. We can't flip the seating. And so for N, we have 8 because there are 8 people in all, 3 men, 5 women. And yeah, I wrote that. And because the 8 is canceling out the first 8 in the 8 factorial, really the 8 factorial is this, but because the 8 at the denominator cancels out the 8, it just basically becomes 7 factorial, which equals 5,040 possibilities. For 11.3, you are taking a test with the. By the way, I messed this question up. I haven't really set sights on which part of it was messed up since I last looked at it, but I'll probably see it. So you are taking a test with a total of 15 questions. 10 of them are multiple choice and the other 5 are short answer questions. Your teacher has required you to only answer 11 questions and exactly 4 short answer questions. All right, so for this one, we're going to be using the combination formulas. And so for the parameters, you're going to be able to choose of the, where is it? So parameters are your teacher has required you to only answer 11 questions, but the most specific parameter is that you have to answer exactly four short answer questions. And this is where I mess up on the question. I probably should have said first two short answer questions or so, but I basically set it in stone that you're gonna, for the equation, it's gonna be 5 choose 4 times 10 choose 7, which, and this is the only way to solve this problem. That's why it's flawed and fallible. And so after I wrote out everything, so you can see for the first line right here, it's just a formula, really. What can I explain? Really, it's just a bunch of canceling out. I'll try my best to explain this. I'm not good at that. So you have 5 factorial over 5 minus 4 factorial times 4 factorial. That will simplify to just 5 factorial over 4 factorial, because the 5 minus 4 factorial equals 1 factorial, and 1 factorial equals only 1. So you can just cancel that out, because 1 times 4 factorial is 4 factorial. And then 5 factorial over 4 factorial, because of cancellation properties of factorial numbers, then we can just cancel out the 4 times 3 times 2 times 1 in factorial or in 5 factorial. So that just drops 5 down. And then for the 10 choose 7, we have 10 factorial over 10 minus 7 factorial times 7 factorial. That will simplify down to 10 factorial over 3 factorial times 7 factorial. I chose to cancel out the 7 factorial in 10 factorial, which makes it 10 times 9 times 8 divided by 3 factorial. 10 times 9 times 8 is 720, and we have that over 3 factorial. 3 factorial is, I forgot. Well, 3 times 2 is 6, so 720 divided by 6 is 120. 5 times 120 is 600. So you have 600 possible ways to answer these questions. For 11.4, I'm pretty sure we're supposed to create a sample space of, if you were to roll a die, a 6-sided die, and at the same time spin a colored top, probably something with 4 colors, red, blue, green, and yellow, at the same time. Like I said, it's self-explanatory, but I'll try to explain as best I can. So, geez, I mean, it's a chart. How do I'll come back to this one if I think of how to explain that one, because really it's just self-explanatory to me. I don't really know how to break it down simpler than that. But I'll go into 11.5. A committee of 5 people are chosen from a group of 11. 7 of them are men, and the other 4 are women. Find the probability that all are men. For this one, I didn't bother writing out or typing out all of the complicated math. We have, of 7 men, choose 5, because all of them are men, and I chose to include the women in all of these, or like the possibility of women or the possibility of men in all of these, even if no men or women are inside that are inside the parameters just for consistency. So we have of 7 men, choose 5 times of 4 women, choose none. All over of 11 people, choose 5, and that will get you the possibility of having that as 5%, which is crazy to me. But when I think about it, like, these are all different people, men, so like, there are a whole bunch of different combinations as to which you can choose these guys, and they'll only like get lower when you start adding in women. For this one, we have at least one is a man. I also fluffed up this question because for this one, at least one is a man is like a set parameter that has to be followed, because there are only 4 women, and to make the committee you need 5 people, and so you can't make a group of 5 with only 4. And so I messed up this question too, but I turned it in, so I couldn't really change it. For the at least one is a man, we have of 7 men, choose 1, and then of or times that by of 4 women, choose 4. All over of 11 people, choose 5, and that will get us 2% for the possibility of that happening. Which, like I said, is at first it's like a really low number, but when we really look at how many men there are, the possibility of there only of 7 only choosing 1 and then choosing 4 women is really is not likely. I'll say that. Number 3 are women and 2 are men. So for this one, we have of 7 men, choose only 2. Times that by of 4 women, choose 3. All over of 11 people, choose 5 for the committee. For this one, the same thing. Just multiplication, canceling. That answer will come out to be 18%, right? Yep. Of a possibility. You see, this one is more likely because it's a pretty well-rounded proportion between the men and women. Almost half, but you can't half a person. That would be pretty gruesome. Exactly one is a woman. Okay, so for this one, I chose not to go with the other way of doing this problem, which would be saying that there are no women, because, well, I don't know, I just did it this way. So of 7 men, choose 4, and then of 4, or times that by of 4 women, choose 1. And that'll get you 30% possibility, which is much higher than the previous one because you have so many more men than women. I mean, what is it, 3? Yeah. And for the sample space, I'll try this again. The reason that we have this sample space organized as we do here is because with the dice alone, if we just look at this top row right here, with the dice alone, you have the possibility of getting 1, a 2, a 3, a 4, and so on. With the spinner top or whatnot alone, this row right here on the further left, you only have a possibility of getting red, blue, green, or yellow. But when you spin or roll the 2 together, you have a possibility of getting red 1, or red and 1, red and 2, red and 4, red and 6, You also have a possibility of getting blue in 2, blue in 6, blue in 3. A same possibility of getting green in 5, green in 4, green in 3. And the same thing for yellow. Or when you roll it with yellow, you get yellow 1, yellow 2, and so on. And that's why the chart is basically like a multiplication table. This is the combination chart of the sample space. All right. Thank you for listening.